Hi everybody, this is the start of chapter 11, which is on something called polar coordinates. So far we've been using the Cartesian or rectangular coordinate system to plot points and to sketch graphs. While of course it's incredibly useful, some shapes and equations are much easier to express using a different system, and that's where polar coordinates come in. In this chapter we'll learn how to describe points using not an XY, but a distance from an origin related and an angle, a related angle. And this is going to open up just a whole new perspective on graphing and functions. What you're looking at in front of you on the screen is a polar grid, which we will get to in a minute. We'll actually work with this, but again, totally different than what we have seen so far. So let's just compare the two to start. What we're used to, a Cartesian or rectangular grid, and what we're looking at now, which is a polar grid. Okay, so this is just nice introduction to that. So let's label this just Cartesian, which is, again, what we've been working on really probably since pre-algebra, right? Versus polar. First, there's a difference in how we even write the coordinates. So we know for Cartesian coordinates, or you're going to see the term rectangular used in some of the directions, we write a coordinate like this, x comma y. And what that means to us is, if we have a Cartesian coordinate plane with an x-axis and a y-axis, to plot the point xy, what would we do? We would start at the origin, we would go over x units and up y units, and then wherever we land, we give it this name, x comma y. Now let's see how that changes on a polar grid. And we'll get to that circular grid in a minute. We're going to sketch some points without it first, but it definitely will be useful for some of the problems that we're doing. You'll see that later down on the page. Okay, now for a polar grid, you technically only need this one ray. I guess it's technically a ray, but we will typically see a vertical one here as well, because it just helps put these angles in perspective that we're going to work with. That first line that I drew there, that is called the polar axis. It corresponds with like what you're used to as the positive horizontal or x-axis. This point right here is called the pole. P-O-L-E, pole. If you want, in some of the graphs that we work with, you can give it a full kind of crisscross there, just again to make the angles a little bit easier to locate. So let's say we wanted to plot a similar point. I'm going to put kind of the same point here, but give it a different name, and let's look at what r and theta look like. To plot that point, I'm not going over and up. I am first rotating theta degrees. Think about what that looks like. So this would be theta, and I'm traveling r units in that direction. Now, that shouldn't look totally unfamiliar. We certainly have worked, we certainly have worked with diagrams like that in the past. This is supposed to be just an arrow. Sorry about that. But that's the basis of how we make graphs in this chapter and when we're talking about polar coordinates. Okay, so let's just practice plotting a couple points. Unlike Cartesian coordinates, a point can be represented by infinitely many ordered pairs. Ordered pairs are just like the thing you see in parentheses, a pair of numbers in a particular order. So again, if I have a point on a rectangular grid, let me just jot this. I'm going to erase this in a second. But if I have a point, let's say here, there's only one way to describe this location. How far over did I go? Maybe that's like 4 and 2. So the only name I could possibly give that is 4, 2. That is not the case on a polar grid. So let's look at one example. We'll plot one together, and then we'll think of other names we could give this point. So let's say, for example, we are going to plot the point 5, 30 degrees. R, theta. I kind of wish they listed those in the other order, like they put 30 first, because that's really what you're going to think about first. You're going to rotate first to that degree measure, and then you'll travel 5 units in that direction. So let's set up a little grid here. I'm going to rotate, picture where 30 degrees is. I'm going to go, so let's say it's about here, but I'm going to go 5 units away. And you could put little marks on there to show it's 5 units, but I'm just going to label it as 5 units. So this point right here could have the name 5, 30 degrees. But it could also have a lot of other names. how else could we move around this grid and still end up or terminate in the same exact spot? Think about that for a second. Let's give it some other names here. I'll put that in quotes here. Other names for this point, 5, 30 degrees. Now, one option is, I've done this before, why don't we just rotate around again? So instead of only going 30 degrees, I'm going to start here. I'm going to make one full rotation and then still stop in the same spot. Think about that degree measure. That's one full rotation, so 360 plus another 30. So I could also call that 5, 390 degrees. I didn't really mention the 5 again, but you still would go the same distance away. We want to end up in the same exact spot. You could also rotate in the opposite direction. We've done this before too. Let's start at 0 degrees. This time I'm going to go clockwise. Remember, clockwise means that's just negative. So let's call that 5, negative 330. Can you see how already that would have, we have infinitely many options for landing in that same location. Now, we can also plot with negative, not just negative angles, but also negative R values. Can you squish that on here still? So let's see, let's do a kind of regular one first. Here's example, let's just call this example 2. Let's plot, let's say, how about 7, 315 degrees. Okay, so I'm going to rotate to 315 first. Even though, again, R is listed first, you're really going to think about the angle first. So think about where 315 is. That's kind of smack dab in the middle of quadrant 4. So I'm going to rotate to 15. And then I'm going to put some markings on here this time. I'm going to go 1, 2, 3, 4, 5, 6, 7 units away. That would land me right here. Imagine that little line keeps going. We'll get to that in a grid, a picture like that in a second. Now, if I wanted to plot, let's just keep going here, negative 7, 315. This is brand new. We haven't done this one yet. I would still go to 315, right? Still in the same spot, but this negative 7 basically means go backwards. Take a, not a U-turn, but a 180 degree turn this way. If you could extend that line backwards, and I'm going to go 7 units in that direction. So 1, 2, 3, 4, 5, 6, 7 this way, my point would land right here. So I could call that point negative 7, 315, or let's think about another name for this. If I want to start at 0 and just describe it as kind of the normal way to name this point, that would be, that's really just a difference of 180, right? So this would be 135 degrees, but then positive 7 units in that direction. That's yet another way to kind of name the location of a point. You can throw negative R values in there. If I wanted to, let's change this first example here. Let's say I want to go back to that point at 7, 315. Here's a little challenge for you. Can you call it negative 7, fill in the blank? You would be thinking, okay, I've got to go 7 units away from, or in the total opposite direction, or 180 degrees from, there's that same angle we just saw a second ago, here. These are equivalent on this graph. Okay, so positive 7, 315, and negative 7, 135. Note that's just a difference of 180 degrees. Can you see the straight line on there? Okay, so again, if I'm plotting, let me just talk through this again. If I'm plotting this point here, negative 7, 135, I'm going to rotate to 135. That would be here, but then go 7 units in the opposite direction. Head that way. Let's try a little bit more like that on the actual grid this time. Okay, let's practice sketching these. We'll do these together, and then you'll have in a later part of the assignment some to do on your own. Okay, let's plot. First up, positive R, positive theta, probably the easiest of the bunch. Let's use the grid here this time. First one up is 2, 30 degrees. So I'm going to rotate to 30 degrees first. My point's going to be somewhere on here. I'm going to go, here's the pole. I'm going to go 2 units from the pole, or basically jump out 2 circles from that center. Right here, let's label this 2, 30 degrees. Let's label them as we go. Keep track of them. Next one up, -3, 90 degrees. So I am going to rotate to 90 degrees first and think about this line. But since it says -3, I'm going to go 3 units in the complete opposite direction, or make a 180-degree turn and basically go 1, 2, 3 units in that direction. So I could call this either its original name, -3, 390, or let's give it, it's not the normal name, like the +r, +θ version of the name. Look where that really is. You see the degree measure there? I really am at 270, and I went 3 units in that direction. Those would be equivalent points in polar coordinates. They land you in the same spot. Let's do 5, -30. So I'm going to rotate. Now this is positive. Just watch. This is a little different than the last one. R is still positive. I'm not doing any weird go backwards stuff. What's backwards now is the angle is negative. That just means rotate in the other direction. So I'm going to go 30 degrees this way. So that puts me at 330. I'm on this line, but I'm going to go 5 units from center. So 1, 2, 3, 4, 5. This guy right here is 5, -30 degrees. And then last one, we've got both -r, -θ. So we're going to go to -45 first. Okay, that's like 315, right? So here's -45. I'm on this line at least initially. But I'm going to go 8 units away from that. Think about that, what that would be. Again, a distance or a difference of 180. So I'm going to go along this dotted line, 8 units in that direction. 1, 2, 3, 4, 5, 6, 7, 8. Lands me right here, -8, -45. Now, we typically will use just the +r, +θ version of the name if we can. But as we start working with equations, some of these negatives are inevitably going to come in, so we want to just make sure we can manipulate them if we want to. Okay, so take a look again at A, B, C, and D as you're doing some practice with this later. These are good examples. You kind of have like every scenario you can. You've got a positive where they're both positive, they're both negative, just one is negative, kind of all the different scenarios that you can. Okay, the next video you're going to do some work going back and forth between Cartesian and polar. Okay, so just make sure you're comfortable with this, and then you'll go on to part 2 when you're ready. Okay.